Section A is 40 marks. Question 1 is MCQ, which will be 15 marks. Let us look at our first MCQ. Ly. What is it a unit of? Length. It is distance, means it will be length, correct? So it is B. Give yourself marks. The diameter of a thin wire. If it is thin wire, I can't use vernier calipers, I can't use meter rule. It will have to be C. Then we come to third one. SI unit of retardation. Retardation is negative acceleration. SI unit will be same as acceleration, means meter per second square, which is B. You are writing it down, and then if you were not able to immediately recall, you have to give yourself a 0. Okay. Then we come to the fourth one. Action, reaction, force act on. Would they act on the same body? No. If I have action, let us say I have action and reaction. So you have, this is the weight which is from the earth on the body, correct? Yeah. And the reaction, supposing this is suspended over here, then the tension that is there, the tension will be on the thread from the body. Understanding? So they are on different bodies. Let us talk about another one. Let us say this is the man who is pushing the wall. So he's pushing the wall. The force is on the wall from this. But the reaction of this wall on the person will be in this direction. So this person will move backwards. Understanding what I'm saying? So it will be from the wall on the boy. First one was on the wall. Second one was on the boy. So they will be on different bodies in opposite direction. So which one it is? Tell me. B, different bodies. Yeah. Now fifth one. On increasing the resistance of the circuit, the current will decrease. Now here you have to remember V is equal to IR. So I will be equal to V upon R. Okay, so I and R, can you see how they are? I is inversely proportional. Okay, also understand that if resistance to the flow of electrons is more, the electrons flowing will become less, no? Okay, more resistance, then current will be so increasing the resistance, current will become less. So that is your A. A ball thrown vertically upwards by a person in a moving train comes back in his hand. This happens due to, now do you know this one was a give reason in 2-3 papers earlier when we solved, and it is because of the inertia of motion. So Newton's which law is inertia? It's giving you, is it the first law of motion, second law of motion, or the third law of motion? Body continues to be in a state of rest or uniform motion. Which law is that? First law. Unless and until a external imbalance force acts on a body. Then we come to number 7. The acceleration produced in a body by a force of the given magnitude depends upon what? Now the acceleration produced by a force. So force is equal to mass into acceleration. So acceleration will be equal to take mass that side. Now those who are not comfortable with this, show the working. So it will be force upon mass. What do they say? Acceleration produced by a force on the given magnitude. A force of the given acceleration produced by a force of given magnitude. Okay, so that means it will be F equal to m1a1 equal to m2a2. They are saying that force is the same, okay, in a body. What it will depend upon? Its mass, correct? Correct. It is the mass. The value of capital G. What is capital G? Not 9.8. Which one it is from here? Which one it is from here? Quickly look in the book. I know some of you will know it by heart, some of you will not. How many of you know it by heart? What is the answer? You have the book in front of you.
B option.
B option it is.
6.7 into 10 raised to minus 11.
Did you all find it?
kg.
It was on which page? Which page did you find it on?
Ma'am, I recalled it.
Very good. So rest of you, come on. Tell me which page. See, I cannot see you, but I can ask you which page it is on. Okay, which means none of you opened the book.
I also recalled it, but it's
Page 83.
5 or 83.
Okay, page 83. Now double check whether they recalled. Is it the correct one? 2 children recalled. Tell fast those who looked at the page 83.
Yes, ma'am.
Is it correct? It is correct. Now those who did not remember.
Ma'am, it is correct.
Those who did not remember, you remember now it is on page how much? 83. And then if you did not get it, give yourself a 0 for that. Okay, so give yourself marks for these. What is your A? Conventional current flows from electron rich region of electron deficient region. That means negative to positive. Does conventional current go from negative to positive? It goes from positive to negative, right? It goes this way.
Yes,
So
ma'am.
this is false, correct?
False.
What is the reason? Direction of the flow of electrons is from high potential to low potential. Electrons flow from low potential to high potential. So
High.
both of them are false.
Both are false.
Okay, now we come to the unit of current is which one of these?
Ampere.
It is the ampere, so that is your A. Right over there, 10th and A. 11th one, the pressure inside the liquid of density rho at the depth h is going to be h rho g.
Yes, ma'am.
Where is h rho g?
A, ma'am.
We come to the 12th one. The unit of atmospheric pressure is value of normal atmospheric pressure is what? 76 centimeters of mercury, correct? Then 13th one, SI unit of upthrust is the force. So SI will be Newton, which is B. Then we come to 14, blah is used to detect direction of the current is galvanometer. Where is it?
D. Option.
Now if you did not know about this, don't give the marks, okay? Then when a body starts from rest, then which of the following is the correct equation? Starts from rest means U is equal to 0. So V is equal to U plus AT will become 0 plus AT means this is correct. What is your B? S is equal to UT plus half AT square. And if U is 0, it will be S equal to half AT square. This is also correct. And this one is V square minus U square equal to 2AS. If U is 0, then V square equal to 2AS. This also is correct. So correct is D option. Now give yourself marks on 15 and I'll take your marks later. Okay, let us come to question number 2 and let's move fast. Question number 2, first part. Strip in the vernier calipers is used to measure. Now the strip of vernier calipers is something like this, and this is the strip that is here.
Depth.
This will be for the depth. Okay, so write over the A and depth. Quickly write. Now B, gravitational acceleration is. Now acceleration, whether it is normal acceleration of the car or bike or vehicle and gravitational acceleration, it will be what? It is V minus U upon T. So it is your rate of change of velocity basically. So it will be a vector quantity.
Vector quantity.
Then we come to C. The dash force is always attractive. Which is attractive in nature? Gravitational. Correct? Because it always attracts the body to the earth. Correct or no? So C is gravitational. Tell me when you finish writing. Excuse me. Done?
Yes, ma'am. Yes, ma'am.
Excuse me. So, E part. The length of the seconds pendulum is nearly.
I think you missed the D part.
This one I missed. Okay,
Yes,
dash
ma'am.
is a device to measure the height at which the aeroplane is flying is altimeter. So write altimeter. Let's come to E. Seconds pendulum, it will be 1 meter. Just write 1 meter. Don't write the statement. Blah has more inertia. Which one will have more inertia? Inertia means more mass, more inertia, right?
So car, ma'am.
Yes.
Car.
Now give yourself marks out of 6. And these are now 4 marks, so that will make it 10 marks. What is the second question A part? Can displacement be 0 even if distance is not 0? Explain. So what you will say? Yes. Correct or no? Displacement can be 0 if distance is not 0. And you will say, for example, with an example, yes. For example, you can write, for example, here. For example, in a body moving in which path?
Circular path.
Circular path, comma, in one rotation, in one rotation, comma, displacement equal to 0, and then in the next line, but distance traveled. No, you don't write like that. Distance traveled equal to circumference. Okay, circumference, which is given by 2 pi r. Okay, understood.
Yes,
That should be enough. So this is 1 mark here and 1 mark here. Okay, so those who have, now somebody told this thing, so if it is not completely written like this, you will put half a mark for this. Yes will be 1 mark. So it would be, if you have not written the reason properly, it will be 1.5 mark out of 2. Give yourself marks that way. An electron has mass. So mass of E bar is equal to 9 into 10 to the power minus 31 kg. Is moving with a linear velocity, means initial velocity is 6 into 10 to the power 7 meter per second. And they are saying linear momentum P, that is m into v, equal to question mark. So 9 into 10 to the power minus, this is 31, right? I didn't see that one. Minus 31, and I said something is odd. Multiplied by u is 6 into 10 to the power. How much it is? 7 only, no? Meter per second square. So that will be equal to 9 6 is how much? 54. And here 31 and 7. Subtracting, so that will give us minus 24. Okay, it will be kg meter per second square. But you'll have to write it as 5.4 into 10 to the power. Remember, we divided by 10, so here multiply by 10. So minus 23.
Minus 23.
So you made it minus 25. So that is wrong. Okay. So writing this and correct substitution in 1 mark, and this is 1 mark by writing this, and even the units are proper, then 1 mark. Any one of these is wrong, just give yourself 0 here. Okay, so out of 2, if this part was wrong, then just give only 1 mark for substitution. If you were not able to recall this formula, then 0, and then you have to revise that. So we have finished 10 marks more. So this was 15 marks and 10 marks now. 6 and 4, 10. Okay, let us come to now question number 3. Question number 3 is 1, 2, 3, 4, 5, 10 and 15 marks this is. A stone and a pencil are dropped simultaneously from top of a tower in a vacuum. Which of the two will reach the ground first? So question
Both of
number
them
3.
reach ground at the same time.
Both.
Ma'am, both will reach the same.
Both reach ground, right? Very fast. Okay, ground same time in vacuum. Okay, so this will be 1 mark, and then in the next line you'll write the reason. What will be the reason? You will say this is as vacuum has no material medium and offers no upthrust. Correct or no?
Yes, ma'am. To the body.
Upthrust, no, to the body, never mind, just put no upthrust. Okay, so hence no resistive force. Okay, therefore both travel downwards. No, both fall with the same speed. With same speed. Okay, understanding. So 1 mark for the reason, so that is your 2 marks. We come to the second one. When a hanging carpet is beaten with a stick, dust particles start falling out of it. Why? Now what is happening? You are imparting the motion to the carpet, but the dust particle will continue to be in a state of rest. So what you will say, this is so as the dust particles continue to be
in a state of rest.
In a state of rest, even when the carpet is imparted with state of motion. By striking it, correct?
Yes, ma'am.
Striking it. And then in the next paragraph you will say, therefore by, see, the facts have to be mentioned. By Newton's first law of motion, the dust particles fall down when carpet moves away. Okay, so Newton's first law of motion is observed over here. Okay, so incorporate the word Newton's first law of motion. If you would not have added that, give yourself 1 mark out of 2. Understanding? Okay, 1 mark out of 2, and circle this so you'll know that 1 mark is out of 2. Define potential difference and volt. Do you know these definitions by heart? If you do not know, just give yourself a 0. Now, how many of you do not know it by heart? Tell fast. Quickly tell me. Is there anyone who doesn't know? Just
Yes,
say me,
ma'am.
ma'am. Okay. Now
Yes,
remember, for the third part A, they are saying potential difference. So your thinking step is V is equal to W upon Q. Okay. And then potential difference, and this is work done, correct? So what will you say? Potential difference is the work done in moving charge. Okay. So how will we say now? Potential difference is now, it is the work done between 2 points in the electric field, right? Because it is difference, no? So what you will say is the work done in moving a unit positive test charge unit positive test charge, that is your Q charge, from one point to another in a conductor. Did you understand? You have to look at the formula. All right. Now we come to B. For B, it is 1 volt they are saying. For 1 volt, again go to your thinking step. Right over here, this is 1 V equal to W means work done means 1 joule upon Q means what? 1 coulomb. Understanding? Hello. Now when I talk about 1 volt, what will I say? It is the 1 volt equal to 1 joule upon 1 coulomb, and formula is V is equal to W upon Q. Okay, so for your B, you will say that 1 volt is the potential difference. What you'll say? 1 volt is the, just write PD just now, when the work done is how much? I've shown in the thinking step. How much is the work done? Is 1 joule in what? What is this Q? Charge. How much of charge? 1 coulomb. So what you will say? 1 volt is the potential difference when the work done is 1 joule in moving how much charge? Moving 1 coulomb charge, moving a charge of 1 coulomb from one point to another in a conductor. Okay, everybody understood how to go about the definitions now? Let us come to the fourth one. Draw the symbols for galvanometer and the open plug key. So right over there, galvanometer. What is the symbol of galvanometer? You have to just show like this, show the circle, and you write over here G, and that is your galvanometer. Okay, or it can be center zero galvanometer will be like this. Okay, it shows the deflection needle. This is your 0 and it will deflect either this side or this side. Okay, but you don't have to show those two arrows. You can show it like this, either G or, if it is ammeter, you will do exactly the same and write over here A. If it's a voltmeter, exactly the same thing and you'll write over here V. But make sure you write plus here and minus here. Okay, understanding? Open plug key. So come to open plug key. Now plug key is looking like this. This is closed. Open means this should be hollow and show one part here, terminal here, and show plus and minus. Understanding? Let's come to the next one. Give yourself marks out of 2. Are you getting 2 out of 2 or how much out of 2? Right over there. Two bodies A and B of masses 2m and 6m are moving with a velocity 3v and 8v. Compare their momentums. Make 2 columns for this. Right over there, case 1 and case 2. This is your fifth subpart. Your m1 is 2m and m2 is 6m. V1 is 3V and V2 is 8V. Momentum is P1 is to P2 will be equal to M1 V1 is to M2 V2. Write into brackets since P equal to MV. Why am I telling you to write this? Because I don't want to give any reason for your teacher to cut your marks. Understanding? So therefore, you will say ratio equal to P1 is to P2 is equal to M1 means 2M multiplied by 3V, and here it will be 6M multiplied by 8V. M got cancelled, V got cancelled, 2 ones and 2 went 4 times here, 3 ones and 3 went twice here. So you have 1 is to 4 into 2 is. Did you understand how this is? Now, if you would not write like this, and even if you get this answer, give yourself only 1 mark. Okay, you write it this way, then only give yourself 2 marks. Is that clear to you? I am telling you this method so that you will not have any problem getting your full marks. Everybody understood? All those who missed the steps? Everybody's clear. We come to the 6th one. Explain the function of ratchet and the sleeve of the screw gauge. Now this I'm keeping for homework. If you know it just now, well and good. Understand and give yourself self-check marks. Out of 2, how much are you getting? If you do not know, just leave it. If you know, then you should just check it with the book whether you know it properly or no. Atmospheric pressure of a place is this. Calculate the depth of water at which the pressure is double than the atmospheric pressure. So they are telling you for the 7th subpart, atmospheric pressure is equal to 10 to the power 5 pascals. Okay, they are saying the depth of water. So I'm writing H water means depth of water equal to question mark at which the pressure of water means pressure water is equal to twice atmospheric pressure means this. Did you understand this part? Everybody understood? Hello? Then you will say pressure of water. What is the formula? H rho G.
H rho G.
Pressure of water is 2 into 10 to the power 5 is equal to H into rho I will need in SI, which is 1000 into G in SI is 10. Okay, so your H will be equal to 2 into 10 to the power 5 upon how many zeros are these? 4 zeros. So what am I going to get? These 4 zeros will get cancelled, only 1 will remain, correct? So that will be 20 meters. Did you understand this part? And here you will say height of water, so that your teacher cannot cut your marks. Now if you would have some problem with this, you will give yourself 0. If you would be able to do this, give yourself the given marks. Okay. Draw displacement time graph of a body which is moving with variable velocity. So variable velocity, if they tell you displacement time, you will first label your x and y, write over there displacement, write over there meter, write this is origin, write over there time, write over here second, show the arrow. Now what does variable velocity mean? If it is like this, then it will be uniform velocity, correct? And if it is variable, means it can be like this. Did you understand? Understood? Or it could be like this. Understanding?
Okay, yes, ma'am.
Okay. Now variable means not a straight line. So out of 40 marks, how much are you getting?
Will keep changing.
Just write over there Let us move to the next one. We have approximately 15 minutes and we have to see how much we can do. Section B, remember, is for 40 marks and you have to choose any 4 questions from here. So you have 1, 2, 3, 4, 5 questions from here. You have to solve any 4 questions. All right. Now let us have little more speed. Question number 4A. Explain effective length of the pendulum. So right over there, number 1, effective length. If you know effective length by heart, give yourself 1 mark. Otherwise, do this for homework. Okay, we come to the second part. 2 factors which determine the time period of the simple pendulum. So for this thinking step is the formula. T is equal to 2 pi root of L upon G. So the 2 factors are here. So what you will say, time period is, and then the first bullet you will say is directly proportional to root of G, means to square root of square root of L, directly proportional to root of L. So directly proportional to square root of L means what? You can't write only length. What you have to write? Effective length. Now if you would have forgotten to write effective, the word, then you will get a 0. Understood? The second one, where is this G in the denominator? So will you write directly proportional? What you will write? Inversely proportional to square root of time period. Understanding how to? Then we come to the B part. B part, what do you understand by the following term of the screw gauge? Now 0 error, positive error, negative error. If you know it by heart, you can give yourself 3 marks. If you do not know, learn it by heart and give yourself 0 if you do not know it, because I have told you by last weekend to complete all the revisions. Okay, if you do not know, write these, and even if you know, write these. If you do not know, consult the book, learn it up and write. Just telling you how to be effective in your revisions. Let us come to C. While measuring the length of the rod with a vernier caliper, figure given below shows the position of the scales. They are saying find the least count. Now in your C first part, least count. What is least count of the vernier? It is the smallest division on the vernier scale upon number of divisions, smallest division on the main scale. I'm just writing here, smallest division on, I'm writing MS means main scale, upon number of divisions on vernier scale. Okay, smallest division is from here to here or from here to here. Isn't this 1 millimeter? Isn't this 1 millimeter from here to here? Isn't this 1 millimeter between 3 and 4? There are 10 equal parts, yes. So each part becomes how much? 1 millimeter. And how much is this? The vernier scale has how many? 10 divisions. And so the least count is 0.1 millimeter, which means 0.01 centimeter. Okay, so this becomes your answer 1. If you do not know this by heart, then you will, this is for 2 marks. They're literally throwing marks at you. Okay, so writing the formula, substituting and getting this will be 1 mark and 1 mark. All right, let us come to the second part. The second part, the reading that is shown. So what is the main scale reading? Main scale reading is between 3 and 4, and after 3 this is 3.1, 3.2, 3.3. and then this is 3.4, but this is where between 3.3 and 3.4 main scale reading is 3.3 centimeter. Okay, then the vernier scale division, which division is coinciding? Is this first division coinciding? No. Is this coinciding? No. Is this coinciding? No. Is this coinciding? No. Is this coinciding? Or this is coinciding?
I think the fifth one is.
Fifth one is coinciding. This one has gone little bit this side, yeah. So fifth one it is. So this is the fifth division. All right. So vernier scale reading will be vernier scale division multiplied by least count. That will be 5 multiplied by 0.01 centimeter. How much is that? 0.05 centimeter. Okay, and then you'll say therefore reading is going to be equal to main scale reading plus vernier scale reading, which is 3.3 plus 0.05. How much is that? 3.35 centimeter. Okay, so this is your answer. So this is also for 1 mark. So you will have vernier scale reading ka 1 mark, and then this will be your 1 mark. If you only could do this much, then it will be from this half mark will be here. Okay, give yourself marks out of that. So we finished with 50 marks. Let us see if we can finish 60 marks. Let us come to question number 5A. First part. Size of the gas bubble inside the water starts increasing as it comes towards the surface of the water, right? So what will happen if you come up? The depth becomes less. So what you'll say, this is so as the bubble moves to the surface, depth of it from the free surface. Some of you will say that we don't quite understand. This is the surface of water, this is the bubble. When it is going up, the initial depth was this, but now it is this much. Can you see the depth is decreasing? Understanding. Free surface, the depth from the free surface decreases. Okay, but when H decreases, pressure also decreases. This makes the pressure on it less as pressure decreases with what? Decrease in
Decrease in depth.
Decrease in depth. Okay, now they say the size starts increasing. So here we have to apply Boyle's law. If the pressure is decreasing, therefore by Boyle's law, which means what? The volume is inversely proportional to the pressure, correct? Yeah, by Boyle's law, the volume of air in it inside it increases. No, don't repeat that now. We already said no, pressure decreases. then
Yes,
don't
ma'am.
repeat. Okay, the volume increases, but what are they saying? Increases in size, no? So comma, increasing its size. Increasing what? The size of the bubble. Understood?
Yes, ma'am.
Okay, then we come to the second one. This was for two, 1 2 3. This is for 1 mark. Pascal's law you have to know by heart. If you know it by heart, give yourself marks, otherwise give yourself 0 out of 1. The third one is state any one machine that works on Pascal's law. Which one it is? Hydraulic jack, no?
Yes, ma'am.
Hydraulic jack. I told you, just remember the names of the machine. If you do not remember even that, give yourself 0. If you remember, then give yourself 1 mark, but write it down later on. As of now, let us finish second question also. What are they saying? This is your question B of question number 5. Pressure of water on ground floor. Right? Pressure ground floor is how much? 80,000 Pascal. And on the first floor, so pressure on first floor, that is equal to 20,000 Pascals. They say find the height of first floor. And then they are also telling you take density of water as 1000 kg per meter cube. What is the value of G? 10 meter per second square. Okay? Hello.
Yes, ma'am.
Now remember, if you want to visualize, this is the building, this is the ground floor, and this is the first floor. Now ground floor will have more depth and the first floor will have less depth. Can you see that? Hello. That is why pressure on the ground floor is more. Did you understand this part? Now this much will be because of the height of the first floor. Did you understand? This is the height of the first floor. So you will say that pressure due to height of first floor will be equal to pressure on ground floor minus what? Pressure on first floor. Okay, how much is that? H rho G of ground floor minus what? H rho G of first floor. Are you with me? Let us call this as H1. Let us call this as H2. Huh. What is common here? Rho and G into bracket what? H1 minus H2. Are you with me? And here pressure due to the height of first floor will be, the pressure on ground floor is how much? 80,000 minus how much? Understanding? How much is this? Tell me. How much is rho? Tell me. How much is G? Tell me. And how much is this? So you will get 1, 2, 3, 4. 1, 2, 3, 4. What did you get? Therefore, height of first floor, which is what? H1 minus H2. Okay. Now this they have given you. Okay, so this will be for 2 marks and this will be for 1 mark. So out of 2, how much you would get? Right here. Anything missing, give 1 mark. Even if you get this and any one of these statements are missing, give yourself 1 mark. Understanding? Understanding?
Yes, ma'am.
If you had no clue about it, obviously you'll have to give yourself 0. What is the second part saying? A body weighs blah in air. So W air is equal to 40 GF and W water is equal to 36 GF. Calculate the RD of the, why did they give only for 3 marks? You will have to give this for 1.5 and 1.5, okay? So you'll have to give here 1.5 out of, so either 0 or 1.5, okay? That's the way you have to work. If the statements are not proper, then 1 mark. If you had no clue about it, 0. Now this will be asking us relative density. So relative density, what is the formula? Tell me. W air upon what? W air minus W water, which is equal to 40 upon 40 minus 36. Okay, you can write GF here so that your teacher doesn't cut your marks. Understanding? Equal to below equal to 40 upon 4.
Therefore, relative density equal to 10.
Huh. Now, if they tell you find the density in SI unit, they can ask you, it will be 10 kg, 10 SI unit, 10 into 1000 kg per meter cube.
Yes.
Density in CGS, 10 gram per centimeter cube. Okay, understanding. Then we come to name a device used to measure atmospheric pressure. This is time pass, it is barometer. Then we come to the second one. State any 2 uses of the device which is used to measure atmospheric pressure. So the uses of barometer, number 1 will be to forecast weather, correct? And the second one is to use as an altimeter, means to determine the altitude of a place. Okay, so this is for 4 marks. So there is 1 mark here, 2 marks here, and the third one will be, we do not feel uneasy under the enormous atmospheric pressure. Give reason. What you'll say, this is so as the enormous pressure of the atmosphere atmospheric pressure of the atmosphere is balanced by what? Pressure of the air inside our body in the blood plus lungs. Hence we do not feel. Okay, understanding? So this was for 1 mark. Now
Yes.
with this we have finished 60 marks. What have we finished? 60 marks. All right, so you're going to count the marks on 60 and let me know. Next we say number A. What is this? What is buoyancy? Now those who have buoyancy, some of you do not have, this is your first of question 6, right over there, BUOYANCY, buoyancy. Leave 2 lines and do that on your own. Okay, then we come to the second part. What is the second part? How is upthrust related to the volume of the body submerged in a liquid? More the volume of the body submerged, more is the upthrust, correct? So what you will say, upthrust increases with, underline the word increases with, increase in volume of body submerged in
A liquid.
full stop, and into bracket, since DIR means directly, PROP means proportional. Understanding? Okay, that is because your upthrust, that is FB. Okay, FB is equal to what? V rho G, correct? So remember this and this. Rho and G are constant. So upthrust therefore becomes directly proportional to the volume of the body submerged. Understanding? We come to
Yes, ma'am.
the
Yes,
third
ma'am.
part. How does the density of the material of the body determine whether it will float or sink in water? So for the third part, what you will say, if density material is less than density water, liquid, no, they have said water, no?
Water.
Huh. Then body floats. Correct?
Yes, ma'am.
Then if density of material equal to density of water, I'll put ditto marks to save on time, okay? Then body just floats. Do you know the meaning of just floats? What is just float? If this is the water, it will be just floating like this. This means floating with some part submerged, but when it is just floating like this is called just floats, and when it is down here, this becomes it sinks. Okay, and then what you'll say, if raw material is greater than raw water, then
Body sinks.
very good. Was it simple?
Yes, ma'am.
Okay.
Yes, ma'am.
So here you have to mark on your own. Okay. Now let us look at water is cooled from 10 degrees to 0 degrees. Show how does the density of water change with temperature range. Now state how they are saying. They are not saying describe or draw the graph. Understood? So we don't draw the graph. What is going to happen? Tell me. Water from 10 to 4 degrees, it will contract and then it will expand, correct? So what you will say, B, first part. When water is cooled from 10 degrees to 0 degrees C, in the next line you will say it contracts from, don't say up to, 10 degrees C to 4 degrees C, correct? Yeah. So underline contracts, underline this, okay? And put comma, and its, no, and its density increases, correct?
Yes.
Did you understand? This should be in one line. Then next line, what you will say, it, I'll have to just it expands from which temperature?
Celsius to
Very good. And its density decreases. Don't say will decrease. Decreases is one word. Will decrease, two words. Progressively lazy. Understood? Hello. Understanding up to here?
Yes, ma'am.
Huh.
Yes,
Then
ma'am.
what you'll
Yes,
say,
ma'am.
thus it is the densest at what temperature? Okay. Understood how to write this?
Yes,
Everybody
ma'am.
should know how to present the work, because I cannot give you papers to write and then tell you how it is to be written later on. It's better that we solve it together, all these things. What does it say? A solid, read.
A solid iron ball of mass 700 grams is dropped in mercury in a beaker. 1. Will the ball float or sink? Give reason.
Okay. Iron ball of mass 700 grams is dropped in mercury in a beaker. So we will write a solid iron ball of mass equal to 700 gram is dropped in mercury. Okay, number one, the ball sink or float. What is the density of iron? It is 7.8. Okay, now they have not mentioned, but we have done sufficient revisions and we know that rho iron is 7.8 gram per centimeter cube and rho mercury means rho Hg. Very good. 13.6 what? Gram per centimeter cube. Then what you will say, since density of iron is less than
mercury.
no, less than that
than
of
density.
mercury. That of means density of mercury. Understood? Huh. Mercury. That of mercury. Therefore, iron ball floats. Floats in mercury. Okay, so underline that. So they said whether it will float or sink. So this will be your 1 mark. This will be your 1 mark. Okay, what will be the apparent weight of the ball? Now, apparent weight of the ball will depend upon how much. Oh, how can we calculate that? They have not given us the density of it also, correct? And volume is not given.
Yes.
So, apparent weight of iron ball will be equal to weight in air minus upthrust. Okay, this is one way. How else can we? Because they have not mentioned anything more. How will I know the volume of the iron ball, right? Okay, sorry, mistake. कितना mistake किया मैंने? बड़ा mistake किया. What you will say? Apparent weight of a ball will be equal to apparent weight of floating body. Correct? Correct? Will be equal to 0. Understood? And right over there, since upthrust is equal to the weight of the body.
Weight of the body.
Floating body. Floating body. Correct or no? Okay, so that is how. Understood?
Yes, ma'am.
Okay?
Yes.
Yeah, sorry, what a stupid thing I made. I made a stupid mistake over there. Doesn't matter. We come to the 7th one. At question number 7a. Till what height will the balloon filled with helium rise in atmosphere and why?
Till the inner pressure of the balloon is equal to the outside atmosphere pressure.
We don't talk about pressure. It is rising because of the upthrust. So why would I talk about pressure? It has to be the upthrust you have to talk about. Okay, so you have to say till the height when upthrust on the balloon equals the weight of the balloon.
Yes.
correct? Now what is the upthrust? It is the weight of the air displaced by the balloon. So you will say below that is till the weight of air displaced by balloon equals what? Underline, equals the weight of body, weight of the balloon. Understood?
Yes,
Okay.
Yes, ma'am.
Till what height? And why? What will I say? Why? This is when the upward force will be balanced by downward force. That is the weight of balloon. You understood?
Yes,
The
ma'am.
upward force will be balanced by the downward force. So uh, so there will be no net upward force. Therefore, there will be no net upward force. Understanding? If both the upward force and the downward force are equal, then the net upward force will not be there and net downward force also not be there. Understanding?
Yes, ma'am.
Okay.
Yes.
Then we come to the second part. What is the next part here? What can you say about the average density of the ship floating in water in relation to the density of water? Obviously, the ship is floating, so average density has to be less. Correct? So what you'll say? Average density of ship is less, underlined, less than that of means density of water. Understanding?
Yes, ma'am.
Now two characteristic properties of upthrust. This is a learning work. You can do this on your own. Right over there. Number 1, 2 characteristics of upthrust. Okay, and right over here bullets, 2 bullets. Okay, you have to write that for homework. Then the second one, what is it? Egg sinks in fresh water but floats in salt solution. Now this also you can write on your own, right?
Yes.
Egg will sink because its density is more than that of fresh water.
Yes.
Okay, but it floats in salt water solution because its density is less than that of salt solution. Okay, then we come to the C part. The piece of iron of density blah and volume blah is completely immersed in water. So we will write over here for C that density of iron is 7.8 into 10 to the power 3 kg per meter cube, correct? And the volume of iron is how much? 100 centimeter cube, correct?
Yes, ma'am.
And then density of water is equal to 1000 kg per meter cube. They are saying number one, calculate the upthrust. Now, what is the upthrust formula? Tell me. It is
V rho
equal
G.
to V rho G. So Vs rho Lg, correct? Volume of the solid is how much? 100 centimeter cube, correct? So I'm going to write 100 centimeter cube. Okay, multiplied by rho L is 1000, but I'm going to write it as 1 gram per centimeter cube. Understood? Because this is centimeter cube. I will write here 1 gram per centimeter cube into G, and you say Haji. Okay, so that will be equal to how much? Equal to 100 G into G and say Haji, and that is equal to 100 GF. Understanding? This G
Yes.
and this G is different. Okay, so 100 GF. So that becomes your answer 1.
Ma'am,
What is the apparent weight?
we are given the value of G. So for after should we?
Listen, as of now, this is in CGS. So CGS, you are not going to make it into dynes. This you will use when it is KGF.
Okay.
Just now, don't do that. Don't
Yes.
touch that.
Yes.
Okay. Now they are telling you apparent weight in water. Now apparent weight in water. So you will have to first find what is the mass of it. What will be the mass of it? Don't like, no? Don't like, no? So we have density is equal to mass upon volume, correct? So therefore mass is equal to volume into density. So therefore you will say mass of iron will be equal to its volume, means 100 centimeter cube, into its density is 7.8 gram per centimeter cube. Okay, now here this is given in SI. So I'm going to write as 7.8 gram per centimeter cube. Understanding? So that will give me centimeter cube getting cancelled, and I'm getting here 780 gram. So W air is going to be 780 GF. Are you with me? And they are saying find the apparent weight. What will be the apparent weight? It is W air minus what? The upthrust. Okay, so that will give us W air is 780 GF minus 100 GF. Okay, so that is going to give me 680 GF. But they gave that value of G, no? So I'm going to write equal to 0.68 kgf. Understood? And then I'll write 0.68 kgf multiplied by 10 meter per second square, and that will give me 6.8 Newton. Did you understand now? Okay, and if you choose to write over here, this will be 0.1 kgf. That will be equal to 0.1 into 10, and that will be equal to 1 Newton. Understood or what?
Yes, ma'am.
Okay, understood how it is? So now you have to see which are the areas where you have to work. Question number 8A. An unloaded ship is filled with ballast at the bottom. Give reason. Now unloaded ship, when it gets loaded, its center of gravity is going to get lowered and it is going to be sinking more. Correct or no?
Yes,
Hello?
ma'am.
So it will lower the center of gravity and it will give stable equilibrium. But did we have stable equilibrium in our syllabus? No. So what will we have to say? Later on when it gets sunk, it has to displace equal volume of water. Correct or no? That means it has to increase the upthrust. Agreeable to you? Yeah. So what you will say? Unloaded ship has uh, center of gravity higher than loaded ship. Hence, its ballast is filled at the bottom so that its center of gravity is lowered so as to attain stable equilibrium. I think this is the most appropriate one. I don't want to bring in that it will displace more volume of water than when ballast is not filled. This should be enough.
Like this is more appropriate reason.
Yeah, because the center of gravity should be sufficiently lowered, and because it should not get toppled over, right? If the center of gravity is higher, it will get toppled over. Put comma and say, and it will not get toppled over in rough sea. Okay. We come to the second part. Will the level of water in the container change when ice floating in it melts? Why? Now this, can you please look at the text and write it? It is ready-made over there. Will you please come to your textbook and tell me which page it is on? Level of water is unchanged. Underline unchanged when ice floating in it melts. Okay, unchanged. Now, where is the reason? What page number? Could you just write it down? Learn it up and write it down. What page number it is? Quickly look. Heat. Found it? Which page number? Come on, come on. These are all learning questions. Anomalous expansion at the back of, at the end of it. At the end of it.
Page 144.
Dikha? Did you find it? Page 144, he says. Are you finding it on page 154? Sorry, what? How much?
144.
144 or 145? Did you find it? Come on, quickly turn to page 144. Quickly. Tell me whether you found it. Jaldi. Yes? No? Those who found it, go to the next part. Barometric height. You have to know this also by heart. Come on. This was your question 8A. Come to B. Tell me barometric height. Number 1. Number 1, right, coming off a storm. Which page it is? Which page it is? Coming off a storm. Leave one line. Dry weather.
110.
Page which one?
111.
111.
111. And the third one, possibility of rain. You can do this on your own, yes? Correct? So this, complete this on your own. You have to know these by heart, okay? Then we come to C. In a hydraulic machine, the force of blah applied at the cross-sectional area of this, what output force is obtained on the piston of cross-section this? So you have case 1 and case 2. You will have F1 and A1, and you'll have F2 and A2. Okay, now remember F1 is 4 Newton here and area 1 is 50 centimeter square. Okay, and F2 is to be found out, so I'll call it as X, and this will be 200 centimeter square. Now remember, hydraulic machine is based on Pascal's law, which means the pressure is going to be equal to F upon A. So F1 upon A1 is the same as F2 upon A2. Are you with me? Hello.
Yes, ma'am.
Now when you substitute, remember this is Newton. So I cannot write the pressure as Newton per centimeter square. So only thing is that over here, you will have to make sure that you convert this into meter square, and that is where your thinking step will be 1 meter square will be equal to 100 into 100 centimeter square, correct? Hello. So 1 centimeter square will be equal to 1 upon 10 to the power 4 meter square. Understanding? So this you will write as 50 into 10 to the power minus 4 meter square. Okay, and this you will write as 200 into 10 to the power minus 4 meter square. This is just so that your teacher doesn't cut your marks, okay? Because the teacher will say, how can you write one quantity for the pressure in SI unit and the other one in CGS unit? I don't want your teacher to cut your marks unnecessarily. Okay, so F1 will be what? 50. No, sorry. F1 is what? 4 Newton, correct? Upon what? 50 into 10 to the power minus 4 meter square is equal to X upon 200 into 10 to the power minus 4 meter square. Alright, now can you see 10 to the power 4 gets cancelled, meter square gets cancelled. Did you understand what has happened? So X stays here, and what are you getting? Tell me. 4 into 200 upon 50, and this is Newton, right? 4 is Newton, correct? So what am I getting? Therefore F2 equal to X equal to 4 into 4 means how much? Did it make sense to you?
Yes, ma'am.
Okay, now will the time, you
Yes,
got
ma'am,
it. Now we come to the second one here. Will the time period of the pendulum change if the mass of the bob is changed from 5 gram to 7 gram? So what you will say, time period does not change, does not, underline that, change on changing mass. Okay, as it is independent of mass. Now some of you will say, ma'am, how do you remember this independent of mass? For this, remember, right over there, T is equal to 2 pi root of L upon G. So time period depends upon the root of effective length and root of gravitational acceleration. Where there is mass here, is there any mass here? So it will not depend upon the mass. Understood? That's why we say it is independent of mass. So that finishes this paper, and we can stop here.